Hello everyone, welcome back to another AP Physics daily problem. Today we'll be going over a dynamics problem. Today we have question 9 from the MIT AP Physics 1 workbook that will be in the description down below for you guys to check out and to follow along. With that being said, let's go ahead and read the question. It says a block of mass 3m can move without friction on a horizontal table. This block is attached to another block of mass m by a cord that passes over a frictionless pulley. As shown above, if the mass of the cord and the pulley are negligible, what is the magnitude of the acceleration of the descending block? So, in this question, we're asked to find what the magnitude of the acceleration of the descending block is. So the block right there. Let me just make this. And here we can see that the block of mass 3m, so the block up here, it says that it's moving without friction on the horizontal table, and then it's attached through a cord over a frictionless pulley as shown above. And if the mass of the cord and the pulley are negligible, meaning they don't add anything, we're asking now what is the magnitude of the acceleration. And with all this known, there are two ways we can solve this. We can either solve this as treating this whole system, we can treat this whole system as one, these, sorry, these two blocks and the tension in the rope and the pulley as one whole system, or we can go ahead and treat them as two independent systems and try to find something that we can get our answer for the acceleration of the smaller mass. So in this video, I'll show you guys how to do both ways. The first way I'll show you is the easier way. So the easier way is to use the equation sum of forces external is equal to the mass total times the acceleration. So this is the same as our Newton's second law, force is equals mass times acceleration. But in this case, when you're doing a system, you're taking the mass of the total system because the system has more than one object in it. So you're taking the total mass of it and you're only calculating the external forces, because the forces internally to the system are not going to add any acceleration. And here we can see that we don't have any friction in the pulley or on the table. So that's a great sign that we can use this equation. So using this equation, we can see that the force external, if we look at our diagram, um, we can go ahead and draw our forces acting on it. So we already said that the tension is something we're not going to add into our forces because it's internal to the system. Here we have on the 3 meters, we have the normal force acting upwards, but the normal force isn't going to add anything to the acceleration since we're going in the horizontal direction. The vertical portion is only force normal, so that's not going to help us at all. But looking at our small block of m right here, we can see that we have a force of gravity acting downwards. And looking anywhere else, that's the only thing that's acting on the object, giving us any movement. So knowing that, we can take our force external, which is just our gravity, is equal to, and the mass total is going to be the 3m plus the 1m. And adding those together, you would get 3m plus m, and multiply that by a. You would, bring this over here, you would get gravity is equal to 4m times a. And now to get the acceleration by itself, because since we're treating this as one system, that means the acceleration for this block is going to be the same as the acceleration for this block since we're treating it as one system. And knowing that, we would just divide this by 4 and divide this by 4, giving us that acceleration is equal to gravity over 4, leading us to choice A being our answer. And the reason we can say the acceleration, as I just said, we're treating this as one whole system, so the acceleration is the same for everything going on here, leading us to the answer. But now there's another way we can do this by solving it without doing this equation of force external. Now the other way we would solve this is by taking our two blocks right here, taking our two blocks and treating them as their own system. So doing that, let's go ahead and do that with the 3m1 block here. So setting up our Newton's second law equation, sum of forces is equal to mass times acceleration. We know our mass is going to be 3m and our acceleration is just going to be 8. And then the sum of forces are what are the forces acting on it. And we can split this into the y and the x components because we know we have in the vertical we're going to have force normal and force gravity acting on it. But since they are on the table, these are going to just be the exact same thing, so these will cancel out. So there's no need in adding those. And the only thing acting on this object is going to be the force tension right here, because as we said, they can move without friction on a horizontal table. So the only force acting on it is going to be tension. So we could say that the force is going to be tension. And then here we have our first equation for M3M. Now setting up our forces in the M for the small box right here, we're going to do the same thing, but we're going to have the sum of forces. Sum of forces is equal to mass times acceleration. Here, we're going to have only two forces acting on it. We're going to be having force gravity pulling it downwards, and we're going to have the force tension. But here is where many people will mess up. We know that our mass is just going to be and our acceleration will just be A. And our forces are force, gravity, and tension. Now, most people would like to just go ahead and say force gravity is negative because it's pulling downwards, but we have to look closely at this problem. Here we know that the block is descending. It's the descending block, meaning that the force gravity is actually going to be positive in this situation. The reason being, the descending block means that it's going to be traveling downwards. And since it's going to be traveling, here, let me make this a bigger so you guys understand. And since it's going to be traveling downwards, that means it's traveling in the positive direction because the force acting in the motion is going to be positive, and the tension is going to be negative because as the block is going downwards, the tension is acting in the opposite direction, meaning it's opposing the distance, or sorry, it's opposing the way the block is supposed to travel. And since it's opposing the intended way the block is supposed to go, it's going to be negative. It's the same with friction. As the block is sliding down the ramp, as the block is going down this way, the friction is acting in the complete opposite direction. And forces acting towards the object's intended direction is going to be positive, and the ones acting in the opposite direction is going to be negative. That's why in this equation, our force gravity is going to be positive because as the block is going down, the force gravity is in the same direction as it, and our tension is the opposite. So I'll make us force gravity as positive and our tension as negative. Now that we have our two equations, we can see that there is something very similar in both equations. Here we have tension up here, and we have a tension down here. And since tension is the same throughout the whole rope, we can go ahead and plug in this tension value for our tension down here. So go ahead and plugging this in, we get that force gravity minus 3ma is equal to ma. And going ahead and combining like terms, we can do plus 3ma plus 3ma, and this gives us force gravity is equal to 4ma. And getting acceleration by itself, we can go ahead and divide by 4m, which is going to be 4m, divided by 4m, and then force gravity, if we remember, force gravity is equal to mass times gravity. So this is the same as saying m over 4m times g, sorry about that, and then the m's do cancel out, giving us g over 4 as our acceleration for A. And knowing that that is our answer, we can go ahead and say choice A is our answer once again. I hope you guys enjoyed the video. If there's anything that didn't make sense or you guys needed to go over again, please feel free to comment down below, and I'd love to go through those questions. I hope you guys have a good day, and remember to enjoy life.